thank you again for joining us today. It's my great pleasure to have the chance to give this presentation. Thank you for joining us. My name's Gareth. We'll talk a little bit about that in a moment. This presentation, statistics and data presentation. So we're going to go through some of the basics, some more complicated areas of presenting your data and statistical analyses, things that you might do to your data before you run analyses, during analyses, or after analyses. Who am I? Well, my name's Gareth. As I mentioned, I currently work as the content director at Research Square Company. I studied in the UK, in Bristol, in the US, in Ireland, worked at the University of Southampton, and have most recently worked at the University of Debrecen in Hungary. I published in my own academic career about 300 or so academic papers, some in good journals, some in less good journals, but many of them highly cited. And I'm also developing content for researchers to help them with their journey, to help researchers around the world understand and develop their skills in writing, publishing, and communicating their research in English and beyond. So once again, thank you so much for joining us today. It's my pleasure to have the opportunity to do this. Everybody attending this presentation will, of course, receive a copy of the video of the presentation at the end. You'll also get access to a certificate and access to lots of other content on AJE.com that we provide to help researchers with their writing and publishing journey. What are we going to talk about today? We're going to talk about, number one, understanding data and the basics of statistical analysis. We're going to talk about your effective data presentation. And then thirdly, we're going to talk about selling the message of your research. What's the point of all of this? The point of all of this is to help you more easily perform analyses, do data presentation, and be more effective as a researcher. So here's a cartoon to get us going. I don't know how to do statistics, but it doesn't matter because I don't have any data. And many of these presentations, many of the work that we do, many of the webinars that we present at Research Square Company are presented, by the way, in collaboration with our friends and colleagues at Bentham Science Publishers. So you'll see a number of Bentham Science Publisher journals. I'll point you to some of their content a little bit later. But if you are looking for a great place to publish your research in a journal with a decent impact factor and a low cost for publication, in particular, if you're going for an open access journal and you want a journal with a decent impact factor, yet a low article processing charge, Bentham Science journals may be the journals for you. Indeed, some very basic definitions to get us going today. What is a statistical analysis? Well, of course, this is an essential component of all scientific research, and of course, a must-have skill for any researcher, which is very transferable, of course, useful in lots of other settings as well, because of course, as you're probably aware, many PhD students, many postdocs who begin their academic careers in academia do not, of course, continue with that track for the remainder of their working life. So statistical analysis, as distinct from one of the other key topics that we're going to cover today, this idea of data presentation, in which you communicate your results clearly and effectively as you put your articles together to tell a story. Very important as well. So the two things are not the same. We are looking for a rigorous scientific method for gaining insights into data, of course. So suppose we measure the weight of 100 patients in a study. With so many measurements, simply looking at the data fails to provide us with an informative assessment and an informative account of what's going on. But analyzing those data with statistical approaches gives us that instant overall picture based on a graphical or numerical summarization or presentation, irrespective of the number of data points. So you're going to drill in to the data that you've collected in a way in which you're able to interpret its meaning and interpret what it is telling you about relationships potentially between variables in that data set. In this case, the weight and patient numbers. So this is the basis of what we're going to be talking about. We are going to be looking at the science of collection, presentation, analysis, and the reasonable interpretation of data. So in this context, we're looking for a numeric set of data, and we're going to describe that set of data on the basis of a number of potential attributes: its center, its variability, and its shape, for example. And so the statistics that you might apply to that data set would have a look at that categorical set of data on the basis of a variable like frequency, percentage, or proportions of things in each category. So we've got data. We're going to have a look at how we can represent that data, how we can present the trends that should be or could be or are present in that data set. And then we're also going to look at how we can present those relationships in the best way in our academic work. Because of course, at the end of the day, that's what this is all about, being able to present the message in our data to the readers of our academic work. And don't forget, of course, that readers are the most important people in the whole writing and publishing process. That's very important. So in our roadmap for statistics and data presentation, we need to look at what data is. We need to look at presenting it in the right way. We need to look at sampling and variation within those data, correlation and causation, and how we can present and differentiate between these variables in both our figures and in our tables. And of course, just with all of our webinars, all of our Research Square presentations, there'll be lots of time for questions and comments and feedback at the end of our session today. But don't forget, you can also at any time put your comments, put your questions, put your feedback there into the chat box. We do welcome that at all times. And if you're thinking of something to do while you're having a listen to this presentation today, don't forget as well, resources.aje.com/digital editing web is a great place to go to get a trial of our fantastic digital editing tool. So let's get going. Let's have a think about what data is. Data are, of course, a collection of facts, values, or measurements, the raw material of science. This is the information that's waiting to be released to help us answer those questions that we are addressing as researchers. How's that done? Through data presentation, interpretation, and statistical analysis. So if you're wondering about the bones of this, the basis of this, that's our starting point for our discussion today. Indeed, presenting data can be done, as you'll see a little bit later, in a number of different formats, depending upon the types of data that you've collected, the numbers, summary statistics and variables, correlations and causation, of course, and we'll drill in a little bit later and talk in more detail about how you can present your data in the form of figures and in the form of tables. By the way, at AJE, if you have a look on aje.com, our main website for professional services, you'll see that we provide a figure generation service. So one thing you can do if you're listening to this and you're thinking, I've got some data, but I don't know how to most effectively present those data for publication, get in touch with us afterwards, get in touch with me at the end of this event. I'll connect you with colleagues within AJE who can help you to put your data into an effective graphical representation for eventual journal publication. And we do have a fantastic success rate when it comes to helping and advising researchers on getting their work published and presenting their data and putting it into leading international SCI journals. So you've got some data. What kind of data do you have? Is it qualitative or numeric, quantitative? So what's qualitative data? Well, this is descriptive data, for example, survey data, information from patient interviews, for example, as opposed to numeric or quantitative data, which could be nominal or categorical, male or female, ordinal, small, medium, large, Integers in the form of countable or rational things, numbers, for example, or quotients or irrationals like fractions, for example. So what kind of data are you collecting? That will influence the ways in which you can assess it for analysis. Just a few general rules. When we write about our analyses in academic papers, numbers up to and including 9 in text. So in your next academic article, numbers up to and including 9 should be written out in full, 1, 2, and so on. Larger numbers, 10 and above, usually are written out with digits. We ask that you effectively round numbers up to 1,000. So we're going to use 6,200 in cases when we're presenting data often rather than the actual number. And for numbers over 10,000, often in academic articles, but this depends on the style of the article, of the style guide, the instructions for authors, you would be using a mixture of digits and words. So 13,000, 1.1 million, not writing it out in full. And it's often believed that the most accurate number is better, but this can often in academic writing imply spurious accuracy and can, in many cases, be misleading. So that's something that you need to also keep in mind. In terms of sampling then, are you considering non-probabilistic sampling where some elements of the population have no chance of selection? The selection can't be accurately determined, so this could be accidental sampling or quotient sampling or purposive sampling? Or are you sampling from a pool of potential data points in a probabilistic way? And by that, I mean that every unit in the population has a chance greater than 0 of being selected. So can you accurately determine that? That's important when you think about how you're sampling for your analysis. So what have we talked about so far? We've talked about some definitions for statistics, definitions for data presentation. We've talked a little bit about what kind of data you might have, qualitative or quantitative. And now we're talking about how you might sample from those data. And so that will lead us into the kinds of analyses that you might end up putting together. So non-probabilistic versus probability-based sampling. And of course, the attributes then are going to vary in each of your experiments. Let's go back to what we talked about before, qualitative variables that can't be assigned a numerical value versus quantitative ones that of course can. So drilling down into this, your data could be discrete, where your values are distinct and separate, they can be counted. Your values could be categorical. Can they be sorted according to categories? Your data could be nominal. Values might be assigned a code in the form of a number, where the numbers are then labels. Are your data ordinal? Can the values be ranked or have a rating scale attached? Or are your data continuous? They may take on any value within a finite or indeed an infinite interval. So things to think about. Of course, again, if you are confused, if you are designing an experiment and thinking about what kind of data you should collect, or indeed how to analyze data that you have already collected and you need help, do get in touch with us because we are able to help you with that. If you get in touch with us, we can connect you with one of our experts. They will sit down with you. They will help you to figure out how to collect the data that you need to test your question, or indeed how to analyze the data that you have already collected. So we start to begin to summarize the data that we have collected as researchers. And often one of the first ways that this is done is via what are called summary tables. Indeed, often this is the first part of academic writing that's done in the process of putting a paper together. The first thing that researchers often do, having completed their experiments or collected all of their data, is of course to sit down and tabulate that data, put that data together. So summary tables are a great way to summarize your data, recording how often each value of a particular variable, for example, is occurring. And you can see a table of number of friends here on this slide, the frequency, the relative frequency, the percentage, cumulative, less than, cumulative, greater than numbers, which help a lot as the author is now thinking about interpreting these data and presenting these data to their readers. So how could you build a summary table? Identify the lower and upper limits in your data. How many classes are you going to have and what their width will be? Then you're going to go in and segment your data into those classes. Each value should fit into one and no more than one class, because of course, in an effective, correct summary table, your classes, of course, have to be mutually exclusive. So have a think about this as an initial way to summarize your data. And then we move on into those fantastic summary statistics to share the shape and the trends that we might see within a data set. So summary statistics, of course, often used to summarize a set of observations in order to communicate the largest amount as simply as possible. So commonly used summary statistics include a measure of location or central tendency, e.g. averages like means, medians, or modes. A measure of spread, for example, standard deviation, how much the data is distributed around the mean. Or a measure of the shape of your data distribution, like skewness, for example, often plotted by use of a histogram. Now, if you're looking at more than one variable, then a measure of dependency is also going to be included in your initial summary statistics, such as a correlation. So we're building out our data. We've talked about the different kinds of data that you might be collecting. We've talked about how you might summarize those data. And now you're going to begin to think about how to assess, how to summarize your data. So consider the following then before putting your data into figures. What type of data are you presenting? What's the main feature that you wish to present? What's your message? How is the information being used and who the intended audience is? We'll come back to this in a moment when we start to talk about data presentation, but your tables, your charts, and your diagrams should assist with the interpretation of your data. They should be representative of the data, not as you frequently see, as we frequently see in lots of papers, that your figures, your tables actually obscure the meaning of the data. You want those trends to be immediately obvious to people reading your work. So we talked about a lot of things, but perhaps most importantly, let's discuss when plotting our data, when presenting our data, the difference between a dependent and an independent variable. Of course, in statistics, rather than in mathematics, the dependent variable is the event being studied. And this is expected to change whenever the independent variable is altered, right? And your ultimate goal, the ultimate goal of every research or scientific analysis is to find those relationships between variables. These are important things for us to think about. And then when we start to discuss those initial measures for variation, the shape of the data, you may very well be looking at things like medians, means, and modes in order to estimate the center of a set of observations to convey a one-liner piece of information about your measurements. We often talk of averages, but that's not precise enough for us as expert researchers. The median is the middle number within a set of ordered data. Below and above the median, there will be an equal number of observations. Whereas the arithmetic mean, that's of course the sum of the observations divided by the number. Whereas the mode, that's the most frequently occurring value in a data set. So averages are okay, but to be precise, what do you actually mean when you're talking about your data? The median, the mean, and the mode. An outlying observation then, similarly, very important for us to discuss, very important often because the outliers in experimental work, in data collection and data analysis, are actually the pieces of information that are most interesting to us as researchers. These could be observations that are numerically distant from the rest of the data. For example, small or large, unusually compared to others. What would the causes of this be? Well, measurement error often, or indeed that your population, that your distribution has a heavy-tailed distribution, which of course is very interesting often in many of the STEM academic disciplines. To look at those outliers and explain those outliers can be where the really important story is in our data. What about symmetry and skewedness? Well, a symmetrical distribution, as you can see here, has the same number of values above and below the mean, represented by the peak of the curve. And in this case, of course, the mean and the median are going to be equal in a symmetrical distribution. Outliers, of course, create skew, but you can discuss initially your data when you start initially at the beginning of your results section to explain what's actually happening by talking about whether your data is either positively skewed, and that would be when outliers are above the mean is greater than the median and the mode, or negatively skewed. If your outliers occur below the mean is smaller than the median and the mode. So basic things to say about your data at the beginning of the results section when you start to describe what's happening in that data set. So your mean, that's your central tendency, but alone, it does not really give us an idea of how the data is distributed. We want to have indications of data variability. Range, variance, and standard deviation, as we've discussed before, are the main ways to do this. So you've got data, you present it in a summary table, you make some figures to look at its distribution, you start to talk about its distribution and its shape with some of the techniques that we've been discussing in this presentation. Now, moving on then to dispersal and variability. You may very well end up talking about the range, the variance, and the standard deviation in a data set that you've collected in your research. So what do these actually mean? Different definitions, of course, exist. This is the standard deviation. So here you have the mathematical distribution, the mathematical definition of the standard deviation. So you can see that here on this slide. That's a fantastic distribution. You can see that, and I can see that. Omar, thank you so much for your question. What software do we recommend for data presentation and data analysis? We are going to come back to that. We're going to jump onto that in a little bit. So which definition you use for this is a matter of preference, but you need to be clear about which one you mean. And have a look here at the difference between the data sample and the parent distribution. Quartiles and percentages as well. What are these? Well, here you can see Q1, Q2, and Q3, dividing a sample of observations into 4 groups. And there you have percentiles, where values that divide the data sample up into 100 equal parts. One of the most common ways that people present their data is using techniques like this, a box and whisker plot. And from these kinds of data presentation summaries, you can see a lot of things about the data distribution, the mean, the standard deviation, the range within the data. So very, very, very useful technique for presenting your data if you're looking at a distribution. In this case, for example, tooth length has been plotted against vitamin C dose there on the x-axis. So we are looking, of course, for correlations. Those are going to be predictive relationships that can be exploited in practice, determining the extent to which values of 2 variables are proportional to each other. And of course, proportional means linearly related. That's in cases where the correlation is high. It can be summarized by a straight line. This is called the regression line or the least squares line because it's determined such that the sum of the squared distances of all the data points from the line are the lowest possible. So correlation is what we want. Is that relationship causation? However, in some of these slides, we drill down in a little bit more detail into some of these correlation relationships, covariance, Pearson's correlation. You can have a look at these slides, I think, when you have a look at this recording later. Some of the definitions here are for you if you're more mathematically orientated. Don't forget, as I've already mentioned, everybody listening to this will be given a copy of our recording as well as a certificate of attendance in this presentation. And what I hope is that in addition to having a look at resources.aje.com/digital editing web, people, colleagues, friends listening to this presentation will also share it with students, maybe use it for teaching, get our message out there so that we can help as many people as possible. Here's a slide that quickly shows a little bit about visualizing correlation. As you can see, when the correlation is higher, the sets of data points will more closely converge onto that linear regression line, which of course is what we want to see. Here's some more information about correlation and covariance, what they mean, what the definitions of these terms are. As I mentioned already, we'll give you these slides. You can have a look at these slides later in your own time. You can use them and the equations on them to help you in your own work. But it's important to be cautious, to be precise, to be careful with your data interpretation, because of course, correlation does not imply cause. Correlation is a measure of linear relationships only, and there could be a misleading influence of a third variable, a spurious correlation of a part with the whole, or indeed the combination of an unlikely population or inference into another unlike population. So as you can see in the little cartoon on the side of this slide, sales relationship to shaved heads. Is there really a correlation? Well, maybe there is, but is that a causative relationship? And you'll be very well aware of all of the jokes and memes and other things that people talk about in this context, like what kinds of correlations can you find between disparate, unlike, unrelated sets of data. Quick definition of what least squares regression is, in which case our goal is to fit a line to a relationship. Don't worry if this is too much mathematics. We do present other webinars in which we drill down a lot more into many of these issues. So if you're listening to this and you'd like a member of our team to get in touch with you and join your postgraduate students or your researchers for a special one-off webinar or series of webinar training events, get in touch with me. We'd love to do that, because our goal at AJE at Research Square is to help as many people as possible. So when you start to put your figures together, when you start to present your data to your audience, to your readers, who, by the way, are the most important people in the academic publishing process. We don't write papers, do we, to just pin them on the wall or give them away to our parents at Christmas. We write papers so that people are going to read them and people are going to cite them and use them in their own research. So what should you have in your figures when you data present, when you talk about your data, when you present your data to other researchers? Make sure your fonts and sizes are large enough to be read. Reference all of your figures in the body of the text. Give all of your figures appropriate self-contained captions. Very important, very common for researchers to download just a figure and its caption from a website, from a PDF, not read the rest of the paper. So you do need to have self-contained figure captions with all of your figures so that there's enough information in the caption for somebody to be able to read and understand what you did without looking at the rest of the paper. Considering where it's best to place your figures as well. And these are common mistakes that researchers make. We've edited hundreds of thousands of papers. We deal all the time with researchers. We help them all the time with their figures, the development of their article, data presentation. If you'd like that service, of course, don't hesitate to get in touch with me at the end of this webinar. But your figures and some of the tips and tricks for presenting your data are in this section of the presentation. And in it, I point you to this absolutely fantastic, absolutely amazing paper that was published in 2014, 10 Simple Rules for Better Figures, published in PLOS Computational Biology. Rule number 1, know your audience. Depending upon your journal, depending upon your target journal, the way that you present your data will be different. will be different. If you're writing up your work for a specialist journal in your own subject area, then of course the way that you present your data will be different to if you're writing up your work for a more multidisciplinary journal like Nature or Science, where lots of people, often not from your own subject area, will get to read the work. So have a think about your audience. That's rule number 1 for making effective figures. Rule number 2 for making effective figures is identify your message. What's the message that you aim to get across with each of your figures? Make sure that your figures are understandable. So you don't want figures that look like this. You don't want figures that are hard to interpret. Rule number 2, what is your message? Rule number 3, let's adapt to the medium. If you're making a figure for a poster or a conference presentation, it might look quite different to the kind of figure that you would make for presentation in an article. So on the left-hand side of the slide, 250 trajectories of a dual particle system. This would be a great figure for a talk or a poster. Whereas what I might put into a paper, into a journal, would look probably more like the figure on the right-hand side, furthest away from rule number 3. Adapt to your medium. Absolutely great advice. Rule number 4, as we've discussed, figure captions that stand alone are not an option. You must put them in, because lots of people download just the figure and its caption. They don't look at the rest of the paper. Be careful about software. Omar asked us about this already. It's important to use a piece of software that you are comfortable with. Don't get pressured by colleagues into using something that you don't know how to use. Very, very important indeed. Rule number 6, using your color effectively. As you can see here, the kind of color tablet, the kind of forms for the color that you use in your figures affects the interpretation of those data. Also, keeping in mind that there are still some journals out there that publish in a printed black and white form. So if you're not paying for color reproduction in the printed journal, you need to pick color palettes that can also be represented if the figure were to be printed in black and white. Don't mislead, as you can see here, rule number 7, whether I plot relative size using disk area, whether I plot relative size using disk radius, and also the scales that I use on my histograms, on my bar charts, can present a misleading impression to the reader. Our job as researchers is to present the data, not to mislead people. So that's rule number 7. Rule number 8, my personal favorite, avoid junk. Here you can see a junky presentation of 7 data series on the left-hand side. Wouldn't it be nicer? Wouldn't it be better to spin it out and present it in a much more effective way? Break out the individual data series, as you can see, done on the right-hand side. And that way it doesn't also need to be in color, which is an absolutely fantastic tip. Rule number 9, message over beauty. The figure doesn't have to be perfectly graphically designed, so long as you get your message across. And of course, lots of journals, lots of publishers will provide you with support once your paper gets accepted. They will worry less about what the figure looks like at submission. They will help you to get the figure into shape. They worry about the science. They worry about the message. So make sure your message is clear. Rule number 9. Rule number 10, Omar, use a tool that works for you. Don't get pressured by your colleagues into using data presentation tools that you do not understand. In terms of figure presentation, these are a better and easier way to present data, a standard way to present and summarize your findings. Readers don't have to struggle then to find information. A picture is worth 1,000 words. So you're going to do data presentation initially. It makes you and your study look more professional, and it's a great way to support your conclusions. And as I mentioned already, putting together data tables, putting together figures is often the first thing that researchers do as they begin their projects. However, you don't need to present all of your data. You could put that into a supplement. This can often be unnecessary and confusing. If your trend is not important, use a table. Use a table if the number of values is small. use a table to complement other data presentation formats. Which is better, table 1 or table 2, when we look at the population of Wales, which is one of the countries comprising the United Kingdom? Which is better? Which is a better way to present the data to your readers? A simple and effective way of data presentation is what you want. Your data tables then should not be filled with grid lines. Sort them, because we read from left to right or from the top to the bottom. Your time should increase from the past to the present, and your size, should increase from small to large. And when comparing numbers, it's of course easier to have those numbers in columns rather than rows. You'll also want to round your data up in summary tables. Left and right justify those numbers. Use consistent and neat formatting. Place your time from left to right or from top to bottom, and put row totals on the right-hand side. Your column totals go at the bottom, and use spaces to separate data, not lines. You want consistent scales and units, a consistent number of decimal places or significant figures, and keep it simple. Now, here's a table from one of our editing jobs that, of course, is riddled with issues. And I'm sure that I don't need to tell you what the issues are. You can have a look at this. You can see that it's a terrible presentation of data. That's not what you want in your papers. Have a think about your audience. What are you presenting? What do you wish to show? And use this as an opportunity to create a usable template for your data, for your presentations, for your tables that you can use in your future publications, that you can use in your future work. That's very, very important as well. Histograms, of course, are graphical representations of frequency tables used to summarize categorical, nominal, or ordinal data. And in these, you have your bars vertically or horizontal, where the area is proportional, to the frequency of the observations falling into that class. So here's a plot of my Facebook friends. You can see on this histogram which categories my Facebook friends fall into, between 0 and 50, and so on along the x-axis. Histograms are fantastic when dealing with large data sets. They allow you to show outliers and gaps in your data to the reader very easily. What about pie charts? Well, these are suitable if you've got categorical data, so data that adds up to a number, or if you wish to show percentages. And of course, in a pie chart, areas are proportional to the value of the category. Here's a pie chart of my Facebook friends. Again, you can see easily where my Facebook friends fall out into that data distribution. But never use a pie chart to show historical data over time, and do not use for data in a frequency distribution. A couple of quick rules for the use of pie charts. Data presentation is really, really important. As you can see here, we won't have a vote, but you can see which of these ways of presenting the same data is easiest for you to understand. I think we'd all agree that choosemyplate.gov down on the right-hand side at the bottom is the best way to present these data. The others are a bit confusing. So that's something to have a think about when you present your data. Coming back to you, Omar, which tools should you use to plot and do statistical analyses? NuPlot, MATLAB, Excel. Again, we have lots of resources available. If you get in touch with us after this presentation, we will point you towards some easy to use software packages, and we will help you with your statistical analyses. Just get in touch, gareth.dyke@researchsquare.com. I'll put my email into the chat box for you so that you have that. It's gareth.dyke, gareth.dyke@researchsquare.com. There it is, goes into the chat box. Get in touch with us after this presentation if we can provide you with any help and any support. What have we talked about? Well, understanding data and the basics of statistical analysis, effective data presentation, and selling the message of your work in order to help you to become more effective at statistics, and at data presentation. We are Research Square Company. It's the largest preprint server in the world. Have a look at researchsquare.com. More than 3.5 million preprints have so far been uploaded to the platform. So have a look at that. There's a link for you here on this slide. We also provide, as I mentioned, high quality technical editing in under 10 minutes through our digital tools. Digital editing, have a look at the link that I pasted in the chat box earlier, resources.aje.com/digital editing web. I paste it for you again there. We have lots of other professional services too. English language editing done by a real person, formatting, figure preparation, journal recommendation, translation services, and grant services as well. Have a look at our services on aje.com. Do get in touch with me if I can provide any further support as a special free gift to you for sticking around to the end of this presentation. You've got there a discount code that gives you, that's right, you, 10% off all of our AJE services on aje.com. The discount